Now we have implemented our service layer. Now the thing is that the service layer is going to actually contain only the business logic for us. In order to implement most of the business logic in modern day applications, we need heavy intervention of data, right? We might have to fetch the data, let's say from a database, or maybe let's say somewhere from the internet, right? So for example, let's say that currently we have not implemented any database yet, but maybe in order to get some product related data, what you can do is you can use, let's say, some third party solutions, like there's a Fakestore API, right? Fakestore API can help you to actually fetch a bunch of data here and there, right? For example, if you make a request on this particular URL, you can see it actually fetches you kind of like a dummy product, right? So in our application, there can be a case that the data that we have to play with might be coming from a database, or it might be coming from, let's say, some other third party service, or let's say there are multiple databases. In some cases, we might need to fetch the data from one database. In some other cases, we might need to fetch it from some other database. The problem is that if you will write or integrate the logic of fetching the data inside the service layer, what will happen is, if at any point of time you need to migrate to some other data source, then you have to actually change your core business logic. That's problematic, right? Because here you will be writing the business logic. If with the business logic you will also write how to fetch the data, then both of them will be very tightly coupled. At any point of time, if you have to change how the data is getting fetched, you have to always keep on making changes inside your service layer, right? And that is not what we might need here. That's not what we will recommend here, right? So instead, what we will do is we will segregate the responsibility of fetching the data, maybe through a database, through a third party service, anything, inside one more layer that we will call as a repository layer. We'll call it as a repository layer. Repositories. Okay. Okay, this will be a repository layer. In the repository layer, this is going to be responsible for fetching the data. So let's take an example. Let's take an example. So let's say I'll write a new file. I'll call it as Fakestore product or Fakestore repository. Fakestore repository.js. Okay, Fakestore repository.js. Now let's say okay, we are going to write a function get products. Okay, what we are going to do here, we are going to use the function get products to actually fetch the data from Fakestore. How do we fetch the data from Fakestore? We need to install Exaios, because this will be a network call coming up here. So npm install Exaios, right? And now once we have Exaios with us, what we can actually do is we'll say a try catch. For the timing, I'll just say console.log error here, and we'll say const response is equals to await Exaios, right? Exaios dot get. Okay, we are going to make a get request, and we'll make a get request to get all products. This URL we are going to use. Okay, and this should be an async function. Right? Now what will happen is, inside the response, we are going to have this kind of a data, an array of products. Okay, so we'll say return response. Okay, that's it. Now inside my product service, currently you can see when we were calling get products, I was just returning these products array, right? Instead, what I can do is I can say const, and let's do one thing. Okay, let's do one simple thing. Let's or maybe let's do it like this. I'll say const repository is equals to, and let's import const Fakestore repository is equals to require repository slash Fakestore repository, and we'll say, and we don't need this now. Okay, and now what we're going to do is we are going to say, when we'll call get products, we'll make this an async function, and we'll call Fakestore repository dot get products, right? Fakestore repository dot get products. And instead of directly using Fakestore repository like this here, what we can do is we can say const repository is equals to Fakestore repository, right? And we'll say repository dot get products. Okay, we'll do more code cleanup in a moment, but for the timing, let's do it like this. Now, at any point of time, if you have to change the repository, instead of Fakestore repository, at line number 7, you will just inject any other repository, and that will start working for you. In your business logic, you don't have to make any change, because other repositories, we are going to make sure that they also have kind of like a similar interface. They also expose get products. Every repository for products API is going to expose get products for us. Okay, so that is going to be something consistent that we are going to keep. In normal plain JavaScript, it will be hard to enforce any kind of a contract that always a Fakestore repository or a product repository should return a get store method. But if you are using TypeScript, then that will be pretty much very easy. But for the timing, let's keep things simple. And now what we're going to do is we'll go to products router. We will go to get products. Now this function get products, we need to make it async. Why do you need to make it async? Because product service dot get products is now what? This is also an async function, right? As simple as that. Let's see what happens. So I'll open my terminal. I'll say npm start. I'll open Postman. Okay, and inside shopcart express backend, we'll say fetch all products. We'll go to fetch all products, and we'll send the request. Okay, looks like the request is halting. Let us see why. Okay, so there is some issue. Why there is an issue? Something went wrong. Converting circular structure to JSON. Let's see, JSON.stringify response product controller.js, line number 31. So line number 31.json. What happened? One second, let's restart once. npm start send. Converting circular structure to JSON. Okay. Let's see what's inside response. Let's print response for a moment. So you can see response is coming up. You can see we are able to fetch the response. It's just that it's not returning the response. So let me just quickly take a look there. Why it's not returning the response. Res.data response. Line number 31, 32. Line number 32. Response. Closes the circle, TLS socket. Strange. This is an async function, and what's inside product router? This is good. Get products, request, response, console.log response, return rest.status, this rest. Okay, let's do one thing. For the timing, if I return an empty JSON, what happens? Okay, it's returning an empty JSON. That's okay. That means here we have some problem. Let's avoid returning the data for a moment. Okay, so there is some problem with this data. Let's see what. Const response is equals to await this response. Okay, and now if I send it, let's quickly try to Google. Let's see. I believe, oh, I got it. Probably what's happening is that this response is of type string. Probably, I believe. Okay, it's an object. Okay. So if I do response of 0, then what? Let's see. It's an object, and this object looks like this. Oh, got it, got it. My bad. Okay, sorry, my bad. So what's happening is that we are doing everything right here. The problem is with the service layer. From the service layer, I'm just returning repository.get products, right? I'm just returning repository.get products. Technically, what should happen is we should say const response is equals to await repository.get products, and we should return response.data. If you remember, in Exaios, whenever you make a call, then in the data property, you have the actual response object. Now things should work. And now you can see things are working. So you can see in the data parameter, now you have all the objects that are coming from Fakestore. As simple as that. So these are coming from Fakestore now, right? Cool. Now the thing is, let's see. If you go to product service now, this is the product service, right? Now at any point of time, if you want to actually change the implementation of, instead of using Fakestore, you want to use, let's say, some database to actually fetch the products, you can actually do that. We need some cleanup most probably here. How we'll do the cleanup? Let's see. So what I'm going to do is I'm going to change it into a class-based syntax. So I'll say class product service. Okay. I'll move these functions inside the class. Now we don't need the function keyword altogether. Okay. Cool. And now instead of this, we will just export the class product service. Now what we'll do is inside the constructor for product service, what we will say is that we'll say this dot repository is equals to, when we'll call product service, we'll pass a repository. So we'll be passing a repository. So we'll say this dot repository is equals to repository. And every time when we have to fetch the data, we'll call this dot repository dot get products. Now you don't need to put the repository here. Okay. And you don't need to put the repository here. Cool. Same changes I'm going to do for Fakestore repository. I'm going to make it a class Fakestore repository, and I'll move this function in the class. Okay. Cool. We don't need any constructor for this Fakestore repository because we'll use the default constructor, as we don't need any parameters there. And now what's going to happen is that in the controller, inside the controller, what's going to happen is that we are going to actually use the product service, right? We are going to use the product service, and for this product service, what's going to happen is that I'll say const product service is equals to new product service, and inside the product service, what we are going to do, we are going to pass a new Fakestore repository object, right? So you can see we are going to create a new product service, and inside the product service, we are going to pass a new Fakestore product repository, and now we are going to call product service dot get products like this. Okay. So this is the class that we are going to get. From this class, we are going to create an object. From this class, we are going to create a product service object, and that product service object is going to actually call Fakestore product repository, right? Product service with Fakestore repo, kind of like this. Okay. Product service with Fakestore repo. Product service with Fakestore repo, or let's just call it product service altogether. That's a better naming. Okay. So now if you will try to send it, you can see still you are getting the same response. And now you can see the service layer is independent of any kind of a repository. Whatever repository you want to inject, you will just pass that in the constructor, and the methods inside the service layer, they are going to directly use it. The product Fakestore repository is one of the repository, and we can prepare more such repositories altogether. But I believe you get my point that why we are segregating out things. Let's say later, instead of Fakestore, we want a let's say Shopify repository, which is going to fetch the data from Shopify. That's going to be using something like that, right? So this is going to be pretty much important stuff that you have to always keep in mind, right? So I can see that we have some good coding implementations already done. So I'll say git add all, git commit -m, introduced repository layer, git push. And in fact, now the power of repository layer is that if let's say we want to, instead of get products, I want to do get product. So I'll say product service await, and let's make this async. Okay, I'll say product service dot get product. We are going to come here get product, and now instead of calling products dot filter, I'm going to again call Fakestore repo. How? We're going to say get product. It's going to get an ID, and that ID we are going to inject here slash plus ID. Okay, and whatever is the response, we are going to send the response back. Okay, save it, and here let's do one thing. Let's send the response directly from here and make the dot data property here. Here also dot data, and now we are going to call slash product slash ID for to Fakestore. Same thing, copy paste I'll do here, and instead of just get products, I'll just pass an ID to get product and make it async. As simple as that. And now if you will try to access, let's say the first product, you can see we are getting the Fajal Ravan details. That's from Fakestore. Second product. See how cool is that, right? How cool is that? So this is the power of repository layer, that now at any point of time, if you want to change the logic, we can just migrate to some other repository and things are going to work fine for us. I'll make one more commit here. Added APIs for repositories. Here we go. So now let's try to implement the create products API as well. So if you go here, add new product. So this API for Fakestore doesn't actually add a product in their data store, but it will help us to mimic a few things. What you need to do, you need to make a post request here. So let's go inside Fakestore repository. Okay. So we'll say async create product. Okay. What data do you want to send? You want to send a JSON, which will be having a product. So I'll send a product. And similar to this, we'll say exios.post. We're going to send a post request. And here, what do we need to do? We need to send this body in the form of a string. So we need to do json.stringify. Okay. So let's first of all try to send the product directly and let's see what happens. Then we'll try to figure it out. Okay. So we'll make a post request here. Cool. Now inside the product service, here in the create product, I'm going to call create product and make it async. Okay. And now you can see I changed the implementation on the service layer, right? But here on the controller, we don't need to make any change. We were still calling create product and we were getting a response, right? All we have to do is just make it async await compliant. Async await. And this should be good. Let's try. So let's say if we try to create a product. And you can see we are getting a response from, you can say the Fakestore API, right? Because now you don't need anything like this here. You don't need the products in memory DB and everything. We are interacting with the Fakestore API and getting our response. You can see it gives back us a corresponding dummy response altogether, right? So you can see this is pretty cool. Okay. So let's do one thing. Git add all, commit -m, added create product API using Fakestore. Here we go. Now, as I mentioned that there can be a case that you might have to connect your own database instead of using, let's say, some third-party service. So we already know about basic databases, like maybe you can use something like MySQL or something, right? Because what will happen is at any point of time, if let's say you have a database, then there are multiple steps, right? You have to connect to a database. because your database might be running on its own particular server, right? There might be a dedicated MySQL server, right? And you have to set up a connection with that MySQL server. There will be a TCP connection set up, and then on the top of that connection, you are going to actually query some data altogether, right? Something like that is going to actually happen, right? Now you can do the same thing inside your Express.js applications as well, right? There are multiple ways in which you can actually set up MySQL DB and actually connect that. So first things first, what I'm going to do is I'll first of all open MySQL Workbench in front of you. Okay, and let's see. So if you carefully see, or let's do one thing. Let's do one thing. Okay, so you can see that there is a database that I already have called as e-commerce API. Inside this e-commerce API, if I do something like use e-commerce API, and let's say I do select star from products, run it, and you can see a bunch of products are coming, very similar, but yeah, some dummy products are definitely coming up, right? So let's say currently my agenda is just one simple thing. What do I want to do is I want to set up a connection between the MySQL server and my Express.js server, and I just want to query the number of products or total products inside e-commerce API, right? This database, the name of the database is e-commerce API. Let's see how can we do that. So first things first, we have something called as a MySQL package. Okay, let me actually show you. So there is a package called as MySQL. What this package actually does is it helps us to set up connection. It helps us to actually set up connection between your MySQL server and your JavaScript application, right? You can see it's a Node.js. Sorry, it's a Node.js driver for MySQL. So it's a Node.js driver. It's a Node.js driver for MySQL. What is the meaning of a driver? So driver, you can say, are additional piece of software that does some underlying piece of things, some abstracted algorithmic stuff that they do, and we can just directly use them. For example, if you have been into like Windows XP, Windows 10, so or Windows 7, then a lot of time you must have heard about a lot of people saying, I have to install a sound driver, I have to install a display driver. What is the meaning of a sound driver? The usage of sound driver software was to make sure that your operating system Windows is able to connect to the sound system of the laptop, right? Same thing here. What MySQL driver is going to do is it is going to make sure that your JavaScript application is able to connect to the MySQL DB. So how can you use that? You can do something like npm install MySQL. This is not going to be the final solution for us. We have one more elegant way to actually connect to MySQL, but let's see how things work. So let's go to the terminal. I'll install MySQL. Once again, what happened? npm install MySQL. Okay, you can see MySQL has been installed. Now what we're going to do, we need to require MySQL. So I'm setting up a basic raw code. I'll delete all of this code. Okay, so let's do one thing. So here I'll say, sorry, const MySQL is equals to require MySQL. Okay, and then what you have to do is you have to create a connection object. What this connection object does is it takes the URL of your hosted MySQL DB. It takes the username of the DB, password of the DB, and the name of the database you want to access. So let's copy this, and let's say I'm going to paste it somewhere here below the port. Okay, so I'm going to create this connection object, or let's make it manually. I'm not sure why this weird spacing is coming up. So const connection is equals to MySQL dot create connection. Okay, we'll call the create connection method. See, create connection, and these properties we have to pass. So the host currently is going to be localhost. Why? Because I want to connect to the MySQL DB currently running on my own machine. This is not on any AWS server or anything. If it is hosted somewhere on some AWS server, you need to pass the host corresponding to that. Okay, then you have to call the user. So let's say the user for my machine is root, right? Let's say there should be a password and there should be a database. The name of the database is, let's say, e-commerce API. E-commerce API. e-commerce API. Okay. Cool. Now you can see these are some pretty sensitive information that is coming up here, right? We should not technically keep them like this. What we should do is we should say db host is equals to localhost. Okay, we should say db user is equals to root, db name is equals to e-commerce API, and db password. Okay, so I'll just quickly bring my db password. I forgot what's the password. Just a second. So just a moment. So this is my password. I'll bring it here, paste it here. Okay, it's just my db password. I'll close it, and instead of this, I'll start accessing it like we'll go to server config, and now we'll access them here. So let's say db URL is process.env.db URL. Okay, and let's say you have db user, db user, db user, db name, db password. Save it, and now we can access all of them here: db name, db pass, db URL, db user. Okay, and now let's pass the variables here: db password, db name, and db user. Okay, save it. Now you can see you have a connection object set up in place. Now this connection object is going to return you a brand new connection object here. This create connection function is going to return you a brand new connection object here. Using this connection object, you can actually connect to your database. So what we can actually do is, let's name it as db, and we'll say once the express server has started, then inside that server I'm going to say db dot connect. Okay, db dot connect, right? And let's say let's make it a async method. Let's await on this, and I guess we don't need to await. Okay, so we don't need to await as such, and so we don't need async here. And this expects a callback, I guess. This callback takes a error parameter, that if something went wrong, if there is an error parameter, then we'll say console.log db didn't connect. Okay, and we'll do console.log error, and we'll say throw error. Okay, cool. And then otherwise we'll say console.log db connected. Okay, db connected. Let's try to run the server. Npm start. Okay, you can see the db has not connected. There's an error coming up, so that means db has not successfully connected. Let's see what's the issue. So db didn't connect. Okay, so it says that client does not support authentication protocol. Consider upgrading MySQL client. Let's do one thing. Root. One second. Is this password correct? Yep, the password is correct. Let's Google this error. Let's Google this error. Okay. So, okay, got it. So there is a package called as MySQL 2, right? So this MySQL is an old package which uses old authentication protocols, right? And in fact, I mentioned, right, that there is a more slightly better way to actually do the MySQL connection, just instead of just directly using the MySQL driver. So instead of this, what we are going to do, we're going to uninstall MySQL 2, npm uninstall MySQL, right? And instead of this, we are going to install MySQL 2. MySQL 2. So there is a driver called as MySQL 2 that uses the latest authentication protocols. So you can say we'll get MySQL 2, npm start, and you can see this time the DB connected. So it was a package issue. As you can see, we are able to connect to the DB. Now, how should we identify whether we are able to connect to the DB properly or not? Right? That should be something that we should be able to identify. So what we should be able to do is, let's say if we are able to connect to the DB, so there is a method called as, let's say, db.query. db.query. We should be able to run some SQL query. So let's say select star from products. Okay, select star from products, and it will give you a callback error comma result. The first parameter is an error, second parameter is a result. This kind of a callback where you have error first is called as an error first callback, where the first parameter is an error parameter. So what now this is going to do is this is going to execute a DB query. We have written the query here, right? And then whatever is the result, it is going to give us in the result parameter. So I'll say console.log result. And if any error will come, we're going to console dot, or let's say console.log error, throw error. Save it. And now, can you see we are able to fetch the data? Can you see we are able to get the data that is coming from the backend, right? And if you see the type of result, it's an object. It's an object, right? If you try to access, let's say, the 0th index of the result, let's see, because it looked like an array, save it. Can you see we are able to access the 0th index of the result? So we are now able to make SQL queries by actually connecting our Express server to our database. Can I see that? And at any point of time, the database has been connected. We can just call this db.query method, write our raw SQL queries. This db.query method takes the first parameter as the SQL query, second parameter as a callback. Inside this callback, there is an error and result. If any error comes up while executing the query, it will be inside the error object, otherwise result. For example, let's say change the table name to produces. Can you see now it throwed an error? What error is it throwing? In the database e-commerce API, this table does not exist. Right? The moment I rectify that, things are working fine as such. Right? So this is how you can actually manually connect your database. So I'll push it, git commit -m, manually connected MySQL DB with Express. Okay, and as I mentioned, there is a more elegant solution to it that is called as ORM. We're going to talk about ORMs in the few next parts, but I believe the basis of how exactly the DB connection works is making sense to everyone. Now, instead of doing the connections manually, there is a concept called as ORM. Now, what's ORM and why do we need it? If you carefully see, whatever tables we have, like products, cards, categories, all of these tables that we have, every table is kind of like representing a real life entity. And to represent real life entities in programming in languages like JavaScript or Java, C++, these kind of languages, we use object oriented programming, right? We use classes, we use objects to represent a real life, I would say, product entity, right? How do we actually manage? Because currently we do select star from products, we are getting an array of products, right? But the thing is that we don't have a defined, I would say, schema inside our programming JavaScript implementation altogether. And we are always very much comfortable in using objects and classes instead of directly representing things in the form of relational data. That's where object relational mapper comes to the picture, ORM. And one of the ORM that exists is called as Sequelize that we can use. What is an ORM? ORM stands for object relational mapper. Now the word object relational mapper is almost sufficient to make you understand what is the meaning of ORM. Object stands for the object in the object oriented programming. Relational stands for the relational in RDBMS. And mapping means this ORM library helps you to map the relational entities into object oriented programming entities. So for example, you have a ORM like Sequelize. So what you will be able to do is you will be able to define kind of like a product class. And when you will be fetching products, then you will be able to fetch them as the instances of that product class. And apart from that, ORMs also help you to write very simple queries. For example, now just think about it. If let's say you have a user class and you want to create a user, generally you do new user or user.create, something like that, right? So you can see, instead of saying insert into users, ID, username, birthday, values, John Doe, and all of this, you can just say user.create. Now, can you see this is more of a object-oriented syntax? Instead of doing select star from users, you can do user.find all. As simple as that. So this is something that you can actually do. Right? So there are a lot of features that they actually provide. You can do associations and everything as well. So let's see how can we get started with Sequelize. Okay. If you click on getting started, first thing is you have to install Sequelize. So just copy the installation command, paste it here. And you can see we have successfully installed Sequelize. Now, Sequelize doesn't only work for MySQL, any kind of a relational database like PGSQL, SQLite 3, TDS, Oracle, any SQL database you can actually use. Now, whatever SQL database you are using, you need to install the driver for that database. And if you remember, we have already installed MySQL 2. We already have MySQL 2 installed for us. You can see that here. So even if you are using an ORM, internally you need a driver that is going to help the application to connect to the MySQL database. Now, how do you connect to the database? Connecting to the database is pretty easy. All you have to do is require Sequelize, right? And then all you have to do is you have to pass your dialect and storage, things like that, right? So actually, let me show you Sequelize connection for MySQL. Okay. So if you go here, see, so you have to require Sequelize, and now you can create a new Sequelize instance. You can give the name of the database. You can give the database username, database password, and then in the host, you can give, let's say, localhost, and the dialect means what SQL interface you are using, that is MySQL. As simple as that. This is how you can actually initialize a new Sequelize object. This will actually help you to connect to the database and also start executing queries. Then what you can do is you can do sqlize.authenticate, and if things work well, then your connection has been established correctly. Then what you can actually do is you can actually start creating model files, something like this, book.model.js, something like this. Okay, I'll show you how the model file looks. This is how the model file looks. Can you see this is kind of like defining books and the schema of the books, that a book will be having a title, the type is going to be string, we cannot allow null, so allow null as false, right? If you remember, not null property tables can have, right? Columns of the tables can have. Author is a string, release date is a date only, subject is an integer, so on and so forth. So you can see you can actually define the whole structure of the table books, right? And then what you can actually do is the Sequelize.define method defines a new model. So you can see you are using Sequelize.define to define a new model, which represents a table in the database. This code block creates a table called books and stores book records, right? Next, you need to add a book model to your database. Now, at any point of time, you have made some changes to your database altogether. What you need to do, you need to call a method called as Sequelize.sync. The moment you will call Sequelize.sync, it will actually create the corresponding database for you. So this is how the flow should look like. Okay, so let's try doing this. Let's try doing this and see if we are able to do something like this or not. Okay, so let's see. Let's do one thing. Let's come up here. Okay, cool. So now you have SQLized setup. Now I'll take the SQLized connection part from here. Okay, so something like this. So now what we're going to do is we have a config folder, right? We have a config folder. Inside the config folder, what we're going to do, we're going to create a new file, dbconfig.js, dbconfig.js. Okay. Here we are going to say const SQLize is equals to require SQLize, and then we'll say const SQLize is equals to new SQLize, and here we are going to pass the name of the database. So the name of the database should ideally come from what? Should be ideally coming from this environment variables, right? So let's say name of the database we are going to keep as shopcart db. Okay, this is going to be the name of the database. So let's bring the name of the database here. So I'll say const require /server config, and we can say db name. We'll pass the db name here. Then we pass the db username. So this is db user. Okay, db user. And if the db name is a new name, if this db doesn't exist, then it will create a database altogether. So currently shopcart db doesn't exist in my database. You can actually see that here. No shopcart db is actually present. So it will actually create the database. Okay, so db user, db password, right? So database user password, and then you pass an object. Inside the object, you mention the host as db URL and dialect as MySQL. Okay, MySQL, and you can say module.exports this SQLize object. Okay, so this SQLize object is going to be pretty much very necessary for doing all of the relevant things for us, right? Now, one thing that I'm going to do is I'm going to remove all of this direct DB connections that we were doing here. We're going to remove that. We're going to remove this MySQL, this. We are going to remove this once again. What did I remove? Okay, so let's remove all of this part. Okay, and let's remove db.connect here. Okay, all of these things we are going to remove. You can see now our index file is still pretty much clean, and all of the SQLize object creation part we have segregated out in the db config file. Okay, cool. Now what you need to do is once you set up the server, once you have started setting up the server, here we are going to use this SQLize object. Okay, so I'll say const db is equals to require /config db config. Okay, so we are going to get the db object, and once the server has successfully set up, we are going to say db.sync, that we are going to call db.sync. Okay, and we'll say await. This is a async await based syntax. It's a promise API. So await db.sync, and we'll say console.log db connected. Save it. And now if I do npm start, okay, it says port is not defined, app.listen port is not defined. Oh, my bad. We should say const port is equals to require server config. Save it. Okay, cool. It says unknown db shopcart db. Once again, I guess it should create the database automatically for us. Let's Google it. Does SQLize create a DB automatically? I believe it should. Calling SQLize.sync, right? Yeah, SQLs can automatically create tables if they don't exist. I'm talking about the DB, not the tables. Just a second. So in our case, I believe I checked. So there is a package called as SQLize CLI, right? And SQLize CLI gives a CLI interface to do a lot of scaffolding. We're not going to discuss that as of now, right? So instead, what we are going to do, let's create a DB. So we'll say create database shop card DB, right? And then we'll try to connect. So it created a database shop card DB, and now let's see. Let's restart the app. And now the DB has been connected, right? So you can see the database has been connected successfully to the shop card DB. But as of now, we don't have any corresponding tables, right? Tables we can directly create using our SQLize package, right? How do we do that? So now table is going to actually represent how the data looks like in the database. And I talked about in the MVC architecture, in the models section, we are going to actually define how the data looks like in your data store. So let's say we are going to define a new model. Let's say we'll call it as category. Okay. Let's say category.js. Okay, category.js. Now, how do you make this work is we'll get your DB instance config/db config. Okay. And then what you can do is you can say const category is equals to let's see one thing. Okay, so we'll say db dot define. So this is kind of like SQLize dot define. Okay, and I'll remove all of this. db dot define. Okay, and now we are going to give the name of the I would say table. So name of the table is, let's say, categories, or let's say category. Okay, and then we have to define the attributes. What all attributes should be there? So there should be a category name. Okay, so I'll put the key as name and the value will be an object. Inside this object, you can actually give the corresponding details about the attributes, that what should be the type. So the type of the attribute should be SQLize. So there is a SQLize object inside the SQLize library, which can help you to get the data types called as SQLize dot, let's say, string, I believe. And we should technically get the whole SQLize object. So SQLize dot string. Okay, so the type of name is going to be SQLize dot string, and allow null should be false. Okay, that this parameter cannot be null. This name parameter cannot be null. Okay, then we are going to have, let's say, description of the category, for example. Okay, description of the category. Again, description of the category is also going to be of type string, let's say. Cool. And one more thing we can actually do is just let me check one second. So if you carefully see now, so we have defined kind of like a category model. You can see we have defined a category model. Okay, and we'll say module.exports category. Okay, so we've defined a category model, and every model file that we create is going to create a corresponding table for us, right? Because I talked about the fact, right? The role of service layer is to make sure you implement business logic. Repository layer is to fetch the data for you. But how the data will look like in your tables, in your whatever data store you have, is going to be defined inside the models folder. That is going to be something that you have to do. Okay. And now let's see. So you can see, let's restart the server. Let's see what happens. Any database changes happened or not. So I'll go to shop card DB. Let's refresh. Shop card DB. You can see currently there are no tables. Currently there are no tables. Why there are no tables? Because currently what's happening is that we have not also integrated, or we have not actually interacted with this particular model, right? We have not interacted with this category model. Let's try to actually interact with this category model. How do we interact with this category model? It's going to be very easy. All you have to do is you get the category is equals to require models slash category, and then you can use very verbose methods like something like this. You can say await category dot create, and then you can pass, let's say, name as electronics, description as category for electronic products, something like this. The moment you save it, and before we save, let's say const response is equals to this, and I'll say console.log response. Okay, so what I'm doing here is I've got the category model from the model file, and on every model we have a dot create method. This is kind of like going to insert a new entry inside our table. The moment I save it, now can you see a lot of things got executed? Let's see what all things got executed. First of all, it's going to create a table categories for us, right? And then if you carefully see, it's calling insert into categories. Can I say that? And now if you refresh, can you see there's a categories table coming up? Inside the categories table, can you see name and description are already there, and there are 3 more columns coming up. So if I do describe shop cart db dot categories, right? Can you see there is an ID parameter which is a primary key? Automatically it will create, because it knows that most of the tables that you need will be requiring some primary key, and it will also give you a created at and updated at. That's every entry inside your table, when have you created it, and if you update that entry, then last when have you updated it. These 3 columns are automatically given to you. All you have to do is define classes like this: db.define name of the table category, and if you carefully see, it automatically pluralizes also. I wrote their category, actually in the table it made it categories, right? Because that makes sense. And we pass an object. Inside the object, all you have to do is just define all of your parameters, right? So once we start actually looking at, you can actually Google about the what all model you can actually create. So model basics, this is how you define a model. Can you see first name, last name, they are defining, okay? And if you actually go to the types, let me show you the types. Creating an instance, you can see how do you create a instance. Creating an instance means creating an actual entry in your table using, you can do something like user.build, user.create, something like that. See, user.create also you can do, okay? And let's see, data types. You can see there are a lot of data types that are actually existing. You can actually read about them, right? You can actually search here as well, data types. Getting started, logging, okay, and let's Google it. Sequelize data types. Okay, so all of these data types. For strings, you have so many options for string, and you can actually read, okay, if you write string, then inside MySQL it means varchar 255. If inside MySQL you want a text, you can use data type as sequelize.text. So you will write sequelize.text if you want to use the MySQL text. Okay, Boolean you have, integers you have, then you have access to decimal numbers, dates you have access to. So all of these things you can actually check. So I'll just paste that as a reference for you guys, so that you can actually check all of the data types, and that's how you can actually define a model. And you can see now we are in a full-fledged state. We are in kind of like a full-fledged state where we have actually access to our models. Now all we have to do is inside our repository we can start accessing these models. But before that, let me commit everything up till here. Added sequelize and category model. Here we go. Now what we are going to do is, let's try to create one more repository. This time we are going to create a new file, product repository.js. Okay. Here, what we are going to do is, just like Fakestore repository, I'm going to copy everything, paste it here. Instead of Fakestore repository, we'll call it as product repository, not repository, repository. Okay. Now, here we don't need to make Exaios calls. We don't need to make Exaios calls. Instead, let's call it as, instead of product, let's call it as, let's say, category repository. Let's rename. Let's call it as category repository. Okay. And we'll get const category is equals to require. From the models, we are going to get the category model, and let's call it as category repository. Now let's start writing. First of all, we'll start writing get categories. Okay. In get categories, what should happen is, we should technically do category dot find all. Okay. This category model is going to give us a find all method. This category model is going to give us access to a find all method, right? You can actually read about that on the documentations as well, right? So if you go to querying a model, defining a model, you can see initializing a model and primary keys. Once again, getting started, querying a model. Okay. So if you want to select, right, see, select queries. So there is a find all method. Find all method, what is going to do? It's going to do select star on the categories table. If you want to find a particular one, let's say find, you can use find one, or you can do find by pk. So let's say, if you want to do a get category, so we are going to pass a category id. This id is going to represent a category id. This is a primary key, right? So we can do category dot find by primary key, and we can pass the primary key here, right? All together. We don't need the data, we don't need dot data here. Okay. And similarly, create category. If you want to create a category, so let's say you are going to get a name of the category and description of a category, and you are going to say category dot create name comma description, right? And you are going to get a category altogether. See, now inside the category repository, I have written all of the methods that are going to be responsible for actually interacting with the database. Now, if in the service layer, if we go to the service layer, we create a new file, category service.js. Okay. And just like product service, I create a category service. Okay. And for the timing, let's avoid these two. I'll just say create category. Okay. We'll get a repository here, category service. And what we are going to do, we are going to say this dot repository dot create category. As simple as that, right? And now let's create a controller. New file, category controller.js. I'll copy most of the things from product controller, paste it here. For the timing, let's avoid these two. Okay. We'll get category service from here. Okay. And we are going to create a new category service, right? And the repository that we will use, we'll say const category repository is equals to require category repository, and we are going to pass category repository here. This is going to give us a category service. Okay. So we'll call category service dot create category, and we are going to pass request dot body as category, and technically we should pass category dot name, category dot description. Okay, see, simple things, right? So what I'm doing here is, from my category controller, I'm calling the category service. So this should be create category. So I'm going to write a method create category, right? Inside create category, I'm going to call category service dot create category and pass the request dot body. Now the service layer, all it has to do is execute the business logic, and in case if it requires data intervention, it will use the repository. So the repository we are calling create category, right? And which repository we are using? We are using category repository, right? We are using category repository. So create category method is coming up from here, which takes the name and description, and internally it calls the models create method, right? So create category, and now we'll say created category. Okay, now let's try to actually add a route for it. We need to add a route for it. So this is the whole flow for an API. You write the repository, you write the model, you write the service, you write the controller, and now you're going to write a, let's say, router also. Category router.js. I'll copy everything from product router like this. Okay. Now we'll call it as category router. Okay. Then we are going to just use category controller. We only have one method create category. We don't need a validator as of now. And we'll be having a post request to category router, which will call create category. See, everything that we already did, we are just repeating everything now. So you can see category routers post request with create category. And now we will go to v1 routes index.js. Any routes that starts with / categories, we are going to route it to category router. Category router is equals to require / category router. Okay. And now let's see. This should be category router. There we go. Now let's try to create a category. Let's try to create a category, add request. Let's see if the server is up or not. Let's turn off the server. So I'll say localhost 3001 /API /v1 /categories. Inside the body, I'm going to pass name as elect, or so let's say kitchenware. And in the description, we are going to, let's name it as kitchenware related products. If I send it, you can see there is no get API, right? There is only a post API. If you see the router, there is only a post API. So send it. And now can you see, we have actually created a category, right? With an ID 3, kitchenware related products. And if you go to the database, first of all, see this query, insert into category. So we have executed a insert into query altogether. And now if I do select star from this, executed, can you see we have a kitchenware coming up, right? As simple as that. So you can see we are able to technically write an end-to-end REST API. And how we did that? We started with the models. We created a model, right? We created a repository. Okay. Inside the repository, we are trying to find the category. We are trying to find one category by the primary key. We are trying to create a category, so on and so forth. Then repositories are going to be called by services. So we go to the service layer. Inside the service layer, we have a category service class, which calls a create category method. Inside the create category method, whatever repository you have passed, that repository's create category method is going to be called. This service is then called inside the controller. So we have a category controller, which just calls the category service, taking the request body, right? And then this category controller method is registered in the routes, where we have registered a post request on / with the prefix being /categories. And that's it. That's how you actually create your first REST API end-to-end with a database interaction. So we'll say git commit -m added first REST API for category creation. There we go.